Algebra Academy. For today's video, the main question is how to sketch a parabola when given a standard form quadratic equation. So in order to make an accurate sketch of a parabola, you need two main things. You need the x-intercepts of the quadratic equation and you need the vertex. And in the previous videos, we learned how to find the x-intercepts. But in this video, we're basically going to cover how we find the vertex. And I found that there are two main ways to do this, using the x-intercepts of the quadratic equation and rewriting the quadratic into graphing form. So then you can find the vertex easily. But in this video, we're going to be covering way number 1, using the x-intercepts. And to learn how to do this, we're going to be using the equation y equals x squared plus x minus 56. Now that we have our quadratic equation, the first step is to factor. And this is a really easy equation to factor because all we need to do is see what two numbers multiply to negative 56 and add up to positive 1, which is our b value of x. So we can see that it's clearly x minus 7 times x plus 8 because negative 7 times positive 8 is negative 56, and then negative 7 plus positive 8 is positive 1, which is our b value. So now that we have our factors, we're basically going to use the zero product property and find our x-intercepts. So this is really easy. All you have to do is take the factors and set them equal to 0. So for our factor of x minus 7, we just take x minus 7 equals 0. And then we isolate x by adding 7 to both sides, and we have one x-coordinate of 7, 0. And then for our factor of x plus 8, we just take x plus 8, set it to 0, subtract 8 from both sides, x equals 8. So one of our x-coordinates is negative 8, 0. So now that we have our x-intercepts, we're going to find the amount of distance that is between them. And that happens to be 15 units because positive 7 is 7 units away from 0, and negative 8 is 8 units away from 0. So in total, plus the 7 units to the right and minus the 8 units to the left, we get a total of 15 units. So the total distance between the two intercepts is 15 units, and to find the point that is exactly in the middle of both these intercepts, we need to take that amount of units, which is 15, and divide it by 2, which gives us 7.5. So whatever is 7.5 units away from 7 and 7.5 units away from negative 8 is the middle. So in order to find that out, basically what we have to do is subtract 7.5 from 7, which gives us negative 0.5, and check if we get the same solution when we take 7.5 and add it to negative 8. And negative 8 plus 7.5 is negative 0.5. So now it's confirmed that our midpoint is negative 0.5. And because the vertex is the middle of the parabola, we know that negative 0.5 is the x value of our vertex. And because it's the x value of our vertex, it's also our line of symmetry. So if you were to draw a line exactly at x equals negative 0.5 for this specific equation, you would cut the parabola exactly in half. So now that we have the x value of our vertex, all that's left to find is our y value. And in order to do that, all we have to do is plug in x. So x equals negative 0.5, we plug that into our original equation, which is x squared plus x minus 56. We could also plug it into the factored form of our equation, so x minus 7 times x plus 8, but I found this easier. And so when you plug it in, you get negative 0.5 squared minus 0.5 minus 56. And that, as you continue to solve that and simplifying that, ultimately you will get negative 56.25 as your y-coordinate for the vertex, which means our vertex for this equation is negative 0.5, negative 56.25. So now we have the two main points that we need in order to sketch our parabola. We have the x-intercepts at negative 8 and positive 7, and we have the vertex. negative 0.5, comma, negative 56.25. So now all we have to do is sketch it. And in order to make a sketch, all you need is those 3 points. So it can look pretty wonky like mine does right here, but as long as it has that information, it is accurate. And we can double check that when we graph the equation on a graphing calculator. And as you can see, both of these graphs have the same main points. They have both the x-intercepts and the vertex.